Yeast is a good chemical factory because it's got metabolism in it that converts sugars into products. Naturally, it converts sugars into ethanol and carbon dioxide, and that's why we use it for brewing beer and wine and making bread. If you reroute the metabolism into other interesting pathways and you put in the genes from a plant, you can get it to produce the molecules that plant would naturally produce. So it's a great chemical factory. And we can scale it in large vats to produce the product we want. My group at the Center for Biosustainability has been working on developing synthetic biology tools to manipulate the metabolism of yeast to produce various products. The first example is about malaria. It's a disease that affects about 3 billion people. In 2017, 219 million people had the disease, and just short of 500,000 died of the disease. There's a great drug for treating malaria. It's called Artemisinin. We get Artemisinin by growing the plant in plantations, extracting the active ingredient Artemisinin from those plants, and then converting it into the derivatives that are used for curing malaria. Many years ago, we engineered yeast to produce Artemisinin. The cost of Artemisinin can be high if it's in short supply, and so by engineering the yeast, we could produce the Artemisinin at a substantially reduced cost. And about 51 million people have gotten access to the yeast-produced Artemisinin. And ever since the yeast process was introduced, the price of Artemisinin, whether from the yeast or from the plant, has stayed low. And so this has been a benefit to people who have malaria all over the world. Having done the Artemisinin story, we decided to turn our attention to things that might be a little more fun. We took the genes that naturally produce these flavors in plants, and we put them into yeast and got yeast to produce the essential flavors that are in hoppy beer. And then that allows us to get the hoppy flavor in beer without using hops at all. Now, you can go beyond this. You could imagine taking all kinds of flavors and putting them into the yeast and getting yeast to produce any one of these interesting flavors in the beer without actually having to add anything else. This yeast is very convenient because you take the hops essentially out of the equation, and it makes the brewing process much simpler. Cannabis. It's even a bigger craze than hoppy beer. Cannabinoids have been used for centuries, really, for treating pain and relieving side effects of various things, and more recently from cancer. There's a big craze in the US now about cannabinoids. The market is expected to hit $60 billion by 2025 and over $100 billion by 2030. So we said, gosh, we ought to be able to produce these in yeast just like you can produce other things. We've engineered the yeast to produce the same cannabinoids that you get out of cannabis, and you do that by finding the synthases in cannabis that naturally produces those molecules, and you put them into the yeast. And so the yeast will produce the natural ones. But along the way, we also found that the yeast is a little sloppy and the enzymes from cannabis are a little sloppy, and that means we can make some unnatural ones that you'd never find in cannabis. So we have this option of making the naturally occurring ones as well as making unnatural ones. And those unnatural ones might make interesting pharmaceuticals in the future. If you've engineered the yeast to produce a lot of it, then that can substantially reduce the energy costs needed. It can substantially reduce the amount of water needed in the case of hops. And all in all, that is an improvement for the environment. By using this yeast platform, we discover a little bit more about the plant pathways, and we discover how to use them in different ways than the plant would naturally use them.